Okay, so welcome to this week's review meeting with a focus on the 1.29 release. We have 4 topics. Vladimir Nachev will start with the workload identity support for the backup credentials. Next up is Dominic with a new feature for VPN2 for configuring multiple IPv4 ranges. Then we have Vladimir Videlov with a change in the networking calico extension about the BERT exporter sidecar. And finally, Alex will show us 2 new CSI drivers that landed in the provider extensions. So then, Vladimir, please get started with the first topic.
Hello. So let me quickly just introduce to what I will show you. Here I have a local setup with Gardener extensions. I just have one seed created, nothing else. And I have a backup bucket that is created, and I will just quickly create one shoot in the background while I'm showing you what actually we will do here. So in this local setup with extensions, I have a WorkloadIdentity setup. One is for the shoot credentials, and other one is for the etcd backup that is used for the shoot clusters. So for this example, we will be using AWS, but this also works for Azure and GCP. So here we do not have any static credentials. With WorkloadIdentity, we define how Gardener to present himself in front of external parties. And here we configure it to present himself in front of AWS. So we will ask Gardener API server to issue ID tokens for this audience. And later the clients will use this config, especially the row IRN. This is the role that will be assumed when they try to connect to AWS. And how I set up the seed cluster here with the values, I just set up the backup for the seed to be using WorkloadIdentity instead of a static secret. And if I switch back to here to the seed and we take a look, it is indeed this one using the WorkloadIdentity. And on the right side is my seed cluster. If I get the backup bucket, it is reconciled, succeeded, and so on. But the most important thing is that if we take the here the controllers are using a secret where the token is synced. So if I describe this secret for the bucket, we can see that it has a token in it and it has a config. So if I, for example, parse the config, there is no credentials in it. So base 64. So if you take a look here, it is that WorkloadIdentity config with the row IRN. And if we take the token, for example, and parse it, it is just a regular, oops. It will be just a regular token. Let's hope. Oops. Sure. Okay, sorry. Okay, so it is just a ID token with some claims, especially the Gardener one. Here we have the bucket identifiers, seed identifiers, and most prominent the WorkloadIdentity, especially the subject. And the similar approach is taken for the shoots. So if we take a look in the shoot namespace, there we have a similar thing for the etcd backup secret. It also have a token field. It has the row IRN and so on. So the etcd backup restore knows how to use these configurations to talk with AWS. And on AWS side, we have a configured identity provider, OIDC identity provider, where my local Garden cluster is configured as the token issuer. And here I have configured a row, web identity row, where I'm assuming, I'm federating external identity with a specific with specific subject and specific audience for this role. So somewhere here there should be also the subject. I'm not sure where exactly it was. Anyway, and finally, this is the backup bucket. And inside this backup bucket, now we have the backup entry that has created a folder for the backup, and the etcd backup restore has uploaded the first backup, full backup for the etcd. I think this is pretty much it. If you have any questions. Nope. Okay. Thanks.
Okay.
I have a
Thank
question.
you,
Sorry. I was wondering about whether we could implement workload identity for generic S3 storage backends, so not the AWS one.
I think it should be possible.
So is there also some form of trust relationship that you could configure in these backends?
It's currently you most probably have to extend the etcd backup restore because it has a couple of different storage providers. But this is implemented only for the AWS S3, for the generic provider. I'm not sure, but I think I have not done it. But it could be extended that if the backend supports the actual backend supports the identity federation, then it should be possible.
Okay, cool.
Yeah, and maybe here the specifics is that in the provider AWS we have some logic to bring the workload identity config and all of these things into the backup secrets, backup bucket and backup entry secrets. So maybe your provider extensions will need to do this, or that could be a bit or requiring more changes. Yeah. Okay. But we can think offline if you want with more details. Okay. Thanks.
All right. Then thanks again, Vladimir. And over to Dominic for the change in VPN2.
Yes. Let me just start the share. Okay, I brought a couple of slides just to give you an overview. Okay, multiple overlapping IPv4 shoot ranges. It's basically a small tweak to the feature of the overlapping CIDR ranges that we brought in recently. The main reason we had this is that technically all of your ranges and your shoots are arrays, so they could have more than one entry, even though most of them have just one entry. But there are extensions like, for example, Iron Core that actually support more than one range. In this case, more than one node range. And the Iron Core people approached us and asked if we could unblock them, basically, because up until now we only mapped exactly one shoot pod range, one node range, and one service range to exactly 1/8 CIDR range. And this is now changing. And now we have the ability to allow more than one range per each of those. So basically what changes is instead of having just one node range mapped to 242/8, we now have all of the possible node ranges that you have defined mapped to subnets of that range. And the same applies to services and pods, of course. And the limitation now means that the total number of hosts in all of your ranges per each of those range types must not be larger than /8. So it basically has to fit still into this range, which should be still plenty of addressable space. So how do we do this? We basically have a recursive subnetting going on here. So we start out with in this case, in the node example, 242/8, and we have on the left side a couple of node CIDR ranges assumed, and the algorithm basically first sorts these ranges by size so that the largest ranges come out on top, so that we don't get any large range surprise later on down the road. And then it basically compares the size here. So we have the prefix length 16 here, and we have the prefix /8. And we basically know, okay, this guy is smaller than this guy. So we have to break this down into /16 subnets. And then we basically take the first one, pop it off this list and assign it to the first addressable range here. And then we rinse and repeat. We basically look at this next one. Okay, we have /16. We already have a couple of free /16 ranges here, and we assign. And then we look at the next one, /24. Okay, we have /16 ready, so it's larger. We have to break it down into smaller ones and assign and rinse and repeat until either we have all of this, these ranges on the shoot node assigned, or we run out of addressable space in this /8. So it's a very straightforward approach, and I think it should cover most use cases, except safe maybe for shoots that have extremely large ranges that wouldn't have fit into this /8 anyway, and then we'll have another discussion. But right now, this should, I think, make everyone happy. As far as we know, we have no customers that have larger ranges than /8. Yeah, the final result is basically a one-to-one mapping of each of those node ranges to one of the subnets of /8, in this case, this 242 range. And the thing that you see in your shoot is a very subtle change. Maybe just let me show it to you. Here I have a shoot deployed that has it has an overlapping node range with which is seed, so it has to map. Let me just go make a small shell here. Show you the difference. Now, instead of having in this case, 242/8 range, we now have a 242/16 range because we have to target only a /16 node range. And as you can imagine, if we had more node ranges here, it would be now possible because we have now more addressable space to map this to, so we would have more subnets of this 242/8 mapped right here. In this case, it's an AWS shoot, so I don't have that, but it's now just possible to map this. Okay, that's it. Very small change, but I think it helps. Any questions?
It might not be as straightforward for people who are not so deep in the networking topic, but I'm happy that you're working.
You may be right on that.
We trust you.
Okay, cool. All right, then over to Vladimir Videlov for the BERT Exporter Sidecar and calico-node.
Hi. Yeah, just quickly to give you an overview. I don't have any slides. So basically, we are using the Calico for our networking and access extension, and because it's working with BERT, we kind of want to extend it to have a more on the monitoring side of observability to check if the state is good or not, and create alerts based on that. So we did sync with the Gartner colleagues and decided to extend the extension and have an exporter to the BERT metrics. We decided to use this BERT exporter package, which is basically looking into the BERT sockets, and this is extending Prometheus metrics that we can then later leverage for alerts and dashboard. And this will be useful for us and maybe for other people to just take to be more aware of the state of this protocol and basically the BGP state of the network. So we did it with additional configuration to the network part. If we go to the networking, there is new setting for the Calico, and it's similar to the Tifo or Felix. It's just enabled and then true and false. Default value is false. If you set it to true, then this respectively goes to as a network resource then later, and reconciled then in the end when the Calico is deployed. The daemon set that it's created for the calico-node will have on the pods, they will have additional sidecar that it's as a sidecar to the calico-node. And then it's this birth exporter, as I told you already, it by default is false and it won't appear. But if you want to use this, you can set it to true, and then this container will show up. What is this container is doing? This, as I said, it's looking into the birth socket on the same host, and then it's exporting metrics. There is kind of a plenty of metrics for this, and we are interested basically only on the birth protocol up and a couple of others. But yeah, after discussing with monitoring experts from Ghana side, we decided we don't want to import everything because we don't want to get too much into Prometheus, and this maybe scale up quite a lot. So we decided just to limit it to very few of them. And just to show you, there is the scrape config that is just selecting the protocol of the prefix export and prefix import count. Just to make this feature complete, not to just import them and not having it visible or something, created a small dashboard that it's basically using the one dashboard that is from the birth exporter repository. I just added what's important for us for the protocol status, which is just counting the protocol up metric, and for all the nodes on the cluster. And the current cluster, there are just 2 nodes, and additionally uptime and yeah, the other 2. Then this is just prefixes imported and exported, maybe useful, but this is just for start. If you want to extend it, we can do that in later on, but for now it suffices. And what's important for us, maybe for others, is the state of the protocol, and we can create later on alerts based on that. Exactly, so this is the metrics that are exported. That is imported in Prometheus, and yeah, we decided to do it as a sidecar to the calico-node daemon set. Because it was a bit easier than this defining additional daemon set, and this container is quite lightweight, so it should be fine like this. Yeah, that's about it. Do you have any questions?
Just wonder if Calico itself doesn't export the state of bird also. I was just wondering, maybe if we need to look at this.
Yeah, that's more question to the Calico network extension people.
Not the free version, if you are talking about BGP metrics, for example.
Okay.
All right then. Thanks, Vladimir, for presenting. And over to Alex for the CSI drivers.
All right. Let me share my screen. Yeah, hello everyone. Today I'd like to share some updates from the infrastructure team. Some time ago we added support for two new CSI drivers, the GCP Filestore and the AWS EFS CSI driver. yeah, we already support the Manila shared file system on OpenStack and the file CSI driver on Azure. Yeah, so let's directly start with the GCP file store. It was quite straightforward to integrate into our ecosystem. Yeah, for those of you who don't know, the file store is the Google Cloud's managed NFS service. And maybe a quick recap, like why would you choose a NFS service instead of a local dist? A NFS allows multiple pods or nodes to mount to the same volume simultaneously, in comparison to a persistent disk, which is local to a VM. So a local disk offers lower latency. So in summary, NFS is a little bit more expensive, but it provides the key benefit of supporting multiple concurrent consumers. Yeah, I've already set up a shoot on dev with the, you can see in the definition, I've enabled the, let me see, where's the configuration, control plane. Oh. Control plane config. There you have the option storage, and under storage files, CSI file store enabled to true. That's all you need to do to get like the CSI driver installed into your cluster. And yeah, for those of you who don't know, a CSI driver is composed of multiple components that run in different parts of the cluster. For example, you have the CSI controller that runs usually in the control plane and that implements the calls to the cloud, like create volume and delete volume and so on. And then you have also like one part that is the CSI node plugin that is a daemon set and runs on the worker nodes. And yeah, that's how we also integrated the files for CSI driver in to our ecosystem. The controller runs on the control plane, and like usually the node plugin runs on the worker, of course. And yeah, I can give you a quick demo. Yeah, this is what I'm here connected to the cluster. I can also give a quick overview. You should see the node CSI driver daemon set. So you can see the CSI driver on the node. And if I would connect to the control plane of the shoot cluster, then I could see that there's the controller of the CSI driver running. And what I've also done in what I've also prepared is I've already created a volume, because you could also only create a persistent volume claim and bind it to your pod, and it would automatically create this persistent volume. However, what the CSI driver does, it creates a file store on GCP, and that usually takes like 5 to 10 minutes. And because of that, I already prepared it. So I have the persistent volume already. However, I have no persistent volume claim. And I've prepared a little demo pod that just stores the date in the volume in the file store volume, and then we can check if it works. Let me apply this. Also created a persistent volume claim that references the persistent volume. We can have a check if it works. Yeah, it's now bound. And the pod should also be up and running. Default namespace. And we can double check if it really prints the date in the volume. And yeah, if I would execute another time, it would print another date. So it is working. Yeah, that's about it. If you want to use an already existing, basically what I just showed is the method if you want to reuse an already existing file store. If I would now delete the persistent volume, it would automatically create a new one. Yeah, so that's about it about the GCP file store. Now I'd like to come to the EFS one. The EFS one was a little bit more complicated to integrate for several reasons. As I already explained, the CSI driver consists of multiple components. And for the EFS one, the image of the CSI controller and the CSI driver is usually the same one. Therefore, one can normally provide a flag to distinguish between if you want to run the controller as on the control plane, on the controller part, or if you want to run the node part. And that was unfortunately not possible with the EFS driver. And we've therefore created an issue on the EFS driver repository, where we also asked to collaborate with them and asked if we could contribute this feature. However, unfortunately, they did not respond to this issue. And also, what's a little bit funny is that they had exactly exactly the same issue with the EBS CSI driver. So yeah, the local CSI driver, and someone of us might know implemented this feature, and they accepted it. Yeah. So because of this issue, we are unable currently to deploy the controller part of the CSI driver in the control plane, but and we have to deploy it. We have to deploy the controller part and the node part both in the chute. Yeah, I've also prepared a little demo. It's basically more or less the same. However, a little bit more happens if you deploy the EFS CSI driver in your AWS chute. We create, first of all, an EFS instance that is needed for the CSI driver. It's not like with the GCP Filestore CSI driver, which on its own creates the Filestore instance. No, for the EFS CSI driver, you have to create the EFS instance. That's what we do for you. We also create mount targets for each zone. We need to create inbound rules to allow traffic from port 2049. Yeah, and then we also create a storage class that maps the instance ID from your EFS instance, and obviously also deploy the Helm chart. And this is the cluster I've prepared, which has the EFS CSI driver installed. And what you can see here is that the controller runs inside of the cluster. And then for each node, I have 4 nodes in this cluster. I have the node CSI driver. Yeah, and we can do the same demo basically. It's the same container. That's the same logic, only mounts this time a EFS instance, and yeah, let's check if it's up and running. There should be a PVC, there should be a persistent volume, and there's also the pod. it prints the date and everything is up and running. One more thing to mention about the EFS CSI driver, there is currently like a bug in the current version that we have deployed on dev. And we already updated it locally. So I'm using here the latest version, which will get deployed with the new AWS extension release next week. So if you want to check out this feature, I would recommend to wait until next week when we have deployed the newest version, because this one has a bug and that leads to crashes sometimes. But that's about it. Do you have any questions?
Currently no questions. Then thanks, Alex, for showing this. And with this, we are at the end of today's agenda. Thanks everybody for joining, and see you again in 2 weeks. Have a good time. Bye-bye.
See you.
Thank you.
Yeah, bye-bye.